All right, welcome back for our next video in which we're going to take a look at how to loop with a for loop. So this is another control structure that's going to be very similar to the while loop. And actually, we're going to start off by looking at some basic code here that I set up that operates using a while loop. So in this control structure, I set up a variable I, gave it an initial value of 0, and then I set up a while loop that's conditioned on the status of I. So this Boolean expression will evaluate as true or false based on what I's current value is. And if it's true, it's going to print out what I's value is. And then I will change, and then it's going to loop back up and evaluate if it's still true or not. So I start off at 0, and I'm checking as long as I is less than 3, it's going to print out I. So I'll go ahead and print this, and you see it gives me 0, 1, 2. It stops at that point because 3 will not be less than 3. So it's going to print out 0, 1, 2. And if I want to make it print out more, I could change this value to say 5 and run it. And then it's going to give me 0, 1, 2, 3, 4. So again, it runs 5 times based on the condition of I. So that's nice. I can control the while loop. I can kind of predict when the while loop will stop because of what I've done, how I've set it up. So usually while loops are used in situations in which you don't know how many times it's going to run. But you can see through this setup that you can actually set them up to control how many times it's going to run. But it's not quite efficient. And that's why we're going to use a for loop instead. Because I'm setting this up, I know it's going to run 5 times because that's how many times I want it to run. But there's an easier way of doing this. Instead of writing this with these 2 lines and this 3rd line, I can take those 3 lines of code and put it into a single line of code. So instead of a while loop, we're going to change this to a for loop. Now for loops are going to take these 3 pieces of code, the initialization, so I'm going to cut that from here and I'll put it inside of here. So int I equals 0, semicolon, and then my condition, I is less than 5, remains there, semicolon, and then my incrementalization comes up into here as well, but I actually don't need this last semicolon. So there's all 3 of those lines are now in a single line of code. And it's going to loop through this now. Now, for extra optimization, I actually only have 1 line of code that's going to be looping. So I don't need these curly braces to identify the block, the loop block, because there's only 1 line of code. So I can further take all those lines of code, condense it down into this much simpler looking, easier to read for loop. So when I run it, I get the exact same results, 0, 1, 2, 3, 4. So again, this is a for loop. I could also go in the opposite direction just to show you some variations on these for loops. They don't have to start with 0. I could switch it from 5 to 0, and as long as it is greater than 0. But instead of adding, I'm going to subtract. And we'll run it, and now we'll see we'll get 5, 4, 3, 2, 1. All right, so numbers are slightly different, but it still ran 5 times. All right, so I could also do some things. I could subtract by 2, so minus equals 2, and this time when I run it, I will get 5, 3, 1. Slightly different, again, using the ability to predict how many times this will run by being able to read the code will be really important. You're going to see questions like this on the exercises. You'll see questions like this on the assessment. So we're going to test whether or not you can evaluate and understand what's happening on this line of code to be able to predict how many times it'll run, and what the results will be. So you could also do things where I would be adding 3 each time, and let's say we start here at 5 and go up to 20. So how many times would that run? Well, let's see. So no times. Why? Well, because I started at 5 and it only runs if I is greater than 20, which it's not. So I had a little bit of mistakes here. Let's go less than 20. And that's what we would call a dead loop, one that evaluates as false from the very beginning, so it actually doesn't ever run. And those are mistakes. So let's run as long as 5 is less than 20, adding to 1, 2, 3, 4, 5, 6, 7, 8 times. And if I add 3, which is what I was trying to do when I made it 32, we get 5 times, because 20 minus 5, 15 divided by 3, which is what you're adding each time, will give you 5 operations. So those are the for loops. Now, in the lab that goes with this, we're going to create a racer class, which is going to extend from the athlete. And one of those methods is going to be a sprint method. The sprint method is going to require the user to say how many times they want the robot, the racer, to move. To write that method, you're going to need to create a for loop. And then when we write the method, we'll put the number in, and then that's going to control the for loop. So the question is, how would we do that? So let's go back to a more simple setup here. As long as I is less than 3, again, we'll do I++. So this, again, will run 3 times. If I wanted to run 5 times, well, then I make this a 5, and it runs 5 times. If I wanted to run 10 times, well, then I make this into a 10, and then it runs 10 times. So again, I want to be able to create this in such a way that I don't have to change the number in the code for how many times it runs. But I don't know what that number is going to be right now. So what would work really well is to create a variable. And as you can see, I've got a scanner here that's going to take in information. So I'm just going to provide the user with a prompt to enter the number to run. Simple prompt. Now I'm going to create a variable to record that. So int num equals input dot next int. So I've asked the user to give me a number. They're going to tell me the number, and I'm going to restore it here in this variable number. That value, number, is going to determine how many times this for loop runs. So that means that variable needs to go in here, because whatever number is will determine how many times it prints. So if I run this, you see down here in the terminal, enter a number to run. If I hit 5, it prints 5 times. If I run it again without changing any code and say 7, it runs 7 times. So I've set this for loop up to be responsive, to be dynamic. It runs a given number of times, but that given number of times isn't determined until the program's in the middle of running and operating. So that's the kind of dynamic programs, responsive programs that if conditions, for loops, switch statements, those can all start to build responsive programs that the user gets to dictate what the program does, but we have to code for those situations and set up structures and code that will respond to what the user wants to happen. And so hopefully you see where for loops can be useful. the content and syntax of the for loop, and how to set it up. If you have any questions, let me know. Hopefully this was useful to help you set up the racer sprint method as well. Again, we'll be working on that in class. If you have any questions, please let me know. Take care.